Solving an equation means that you're trying to find the value of one of the variables when all of the other variables are known. Ideally, you should be rearranging your formula so that the variable you are trying to solve for is isolated. At this point, you can substitute all known values to solve for that variable. Sometimes it's not going to be possible to isolate for one of the variables if the equation is a quadratic. And quadratic means that the biggest exponent that you're going to see is a 2. Okay, so it's going to be squared. If this is the case, you can use the quadratic formula. The quadratic formula will be given to you on all your tests, so you'll be able to use this formula, and this is it here below. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now we're going to get into what a, b, and c represent once we do a problem that requires the use of the quadratic formula. Okay, so let's start doing some questions. So our first question is asking us to isolate for y. So we have 5x plus y equals 7. So we just want the equation to look like y equals something where there's nothing left on the left side. All that you see is y on the left side. So I'm going to write y equals, and I'm going to move this 5x to the other side of the equal sign. So I still have a 7 here, and when I move the 5x over, we need to remember every time we move a variable from one side of the equal sign to the other, the sign changes. So over here, this used to be a positive 5x, and when we move it to the other side, it becomes minus 5x. And that's it, we've isolated for y. Okay, so let's do that again in part B. So in part B, we want to move over the 2x and the negative 5 to the other side of the equal sign. Now the 0 is here but really is nothing, so we can just ignore that there's anything there at all because it's a 0. So I'm going to keep my 3y where it is and my equal sign, and I'm going to move the 2x to the other side of the equal sign, now making it negative 2x because it used to be positive, and I'm going to move my 5 to the other side, now making it positive 5 because it used to be negative. Now when you isolate for a variable, it has to be alone. There can't be this 3 over here. So we need to get rid of the 3. So right now, between the 3 and the y, there's an invisible multiplication sign. And to get rid of that, the opposite of multiplying is dividing. So what we're going to do is divide everything by 3. So I'm going to divide this term by 3, this term by 3, and this term by 3. Remember, whatever you do to the left side of an equation, you have to also do to the right side. So the 3's here cancel out, and we're just left with y equals negative 2 over 3x plus 5 over 3. And that's it. Okay. So if you feel like you know how to do these questions, I recommend that you pause the video, try them out, and then unpause the video and see whether or not you're doing them all correctly. Okay, I'm going to move on to part C. So in part C, we have more than one term that has a y in it, and more than one term that has x's in it, and more than one term that is just plain numbers. So what we're going to do is we're going to keep every term that has a y in it on one side of the equation, every term that doesn't have a y to the other side, and then we're going to collect like terms. Okay, so I'm going to keep my y's on the left side of the equation, so I have negative 5y minus 4y. Okay, remember that the sign that belongs to the 5 is the sign that's before it, so negative 5, negative 4. Those go together. Equals, and now we're going to move this 8x and this 3x to the other side of the equal sign. Remember that when we move terms to the opposite side of the equal sign, their sign changes. So the 8x becomes negative 8x, and the 3x becomes negative 3x. Okay, there's a 2 that's there already, so that's a plus 2. Okay, there's no sign in front of it, so that means it's a positive. And I'm going to take this positive 7 and move it to the other side of the equal sign with the 2, making it negative 7. Now it's time to collect like terms. Negative 5 and negative 4. So if I collect those two terms, negative 5 minus 4, I get negative 9y. Equals negative 8x minus 3x. So those are like terms because they have the same variable. Negative 8 minus 3 is negative 11x, and then 2 minus 7 is negative 5. All right, one last step. We need to get rid of that -9 that's in front of the y. So I'm going to divide everything out by -9. -9, -9, and -9. So my -9's cancel out here, and I'm left with y equals the -11 over -9 reduces two negatives, make a positive. So I end up with just 11 over 9x. Same with the -5 over 9. I can reduce that and get plus 5 over 9. Because when you divide a negative by a negative, you get a positive. And that's it. That's my final answer. Okay, now we're on to D. So in part D, we want to solve for this y value, but this whole thing is being squared. Okay, so think about what you would do to solve for that y. Now a lot of people, when asked, will say, oh, I need to expand this bracket out. Expanding it out means writing it out twice, 2y minus 5, 2y minus 5, and then foiling it. So 2y times 2y, 4y squared, 2y times -5, -10y, -5 times -2y, minus 10y, and then -5 times -5, which is plus 25, equals x. But if you choose to go that route, you're actually making it quite difficult for yourself, because now you've got y squares and y's in here, and you're trying to isolate for y, but it makes it really difficult because y is present in two different forms, y squared and y. And you can't collect those like terms because they're not like terms. Y squared is different from y, so we can't just add or subtract all these terms with each other. Okay, so there's another approach that we're going to use instead. I'm going to erase this. So what we're trying to do is isolate for this y over here. So we're going to just slowly remove everything that's surrounding the y, starting from the outside in. So we're going to start with this 2. So I'm going to get rid of this 2 over here, the squared. Now think about what is the opposite of squaring something. So the opposite of squaring is square rooting. Now we have to remember that when you try to get rid of a square by square rooting, we need to put a plus or minus in front of the number. So for example, let's say we have x squared equals 9, and we want to get rid of the squared. So we would square root both sides, and remember this plus or minus. Now the opposite of squaring is square rooting, so these two will cancel out and we're just left with x equals the square root of 9 is 3, and we need to remember that plus or minus. Now why is that important? Because if x was positive 3, then when we put it into this equation, x squared would be 9, because 3 squared is 9. So that's right. But we'd be missing half of our solution if we forgot the minus sign, because -3 all squared is also 9. So we need to remember this plus or minus that goes in front of the square root sign. Whenever we're trying to get rid of a squared, we have to plus or minus square root. Okay, so that's the first step here. The first thing we're going to do is square root both sides, but remember the plus or minus. So when I square root the left side, looks kind of messy, I'm going to square root the right side, but remember the plus or minus there. Now what happens on the left side? The squared and the square root cancel each other out. So I'm just left with what was inside the bracket. 2y minus 5 equals plus or minus root x. Okay, now we're simply just isolating for y like we were before. So let's move this -5 over to the right side. I can bring it to in front of the plus or minus or after the root x. It doesn't really matter. I'm going to put it in front because it looks a little bit better that way. Okay, and then my final step is to get rid of that 2. So I'm going to divide both sides by 2. And I'm left with y equals 5 over 2 plus or minus root x over 2. And that's it. Okay, so I've isolated for my variable y. All right, so let's move on to the next page. So question 2 is asking us to solve for y if x is 3. So it's telling us what the value of x is. It wants to know what is the value of y. So anytime you need to find a value when another one is known, you just substitute this value of x into all the variables where you see x in your equation, making sure you put them in brackets. So I'm just going to rewrite this, but instead of my x, I'm replacing it with a 3 in brackets. Okay, you can show all your steps if you like. You can type this on your calculator if you'd prefer. I'm going to show the steps here. I have 5 times 3 is 15, minus 3, 15 minus 3 is 12. So I get y equals 12 as my final answer. Okay, so again, I think you can probably continue on your own if you feel comfortable with it. Move on to all the other questions, the other parts in question 2. Pause the video and then come back and rejoin us when you're ready. Okay, so B. Again, we're saying that x is equal to 3, so I'm just going to rewrite the equation, replacing all my x's with a 3 in brackets. Okay, so if you were to type this on your calculator should know bed mass, which means the order of operations. It should know which order everything is done in, and so you should be fine. If you're going to do this by hand, then you just want to make sure you're doing everything in the correct order. So just as a quick recap, I'm just going to write bed mass as a reminder. Bed mass tells us we do brackets first. If there's anything in brackets we need to do, exponents second, division and multiplication next, and then addition and subtraction last. Okay, so we can't multiply 2 times 3 until we do 3 squared, which is exponents. So 3 squared is 9, so I'm left with 2 times 9, minus 3 times 3, which is 9, plus 5. Okay, next we're going to do division and multiplication. So the multiplication, 2 times 9 is 18, minus 9 plus 5. And now we can do all of these at once. 18 minus 9 is 9, 9 plus 5 is 14. So our answer is 14. Okay, again, you should be able to just type this directly into your calculator and get the correct answer. Try it out on your calculator and make sure you're getting the answer as 14. All right, C. So again, we want to solve for y when x is 3. So I'm going to replace all my x's with a 3 in brackets. So I have 3 times 3, which is 9, minus 1, over 3 plus 2, which is 5. 9 minus 1 is 8, over 5. And that's it. All right, this time we need to isolate for our y first before we should start substituting in values for x. If you decide to substitute your 3 for x right away, you should still get the same answer, so it's totally fine as well. I'm going to rearrange the equation to isolate for y first, which means I'm going to take this 2x and the 7 to the other side of the equal sign. So I'm going to leave my 3y, my negative 3y where it is. I'll bring my 2x first. So now that it used to be positive on the left side of the equal, now I'm moving it to the right side of the equal sign, so it's going to be negative 2x. And my 7 used to be positive 7, now it's going to be minus 7. Okay, we have a negative 3 in front of our in front of our y, so I'm just going to divide both sides by negative 3. And then simplify. So the negative 3's cancel out. I'm left with y equals, the negatives cancel out, so I'm just left with 2 over 3x plus 7 over 3. All right, so now I'm ready to substitute my value of 3 in for x. So I have y equals 2 over 3. Instead of x, I'm subbing in a 3 plus 7 over 3. You can do this on your calculator as well, but I'm going to do it by hand. So I have 2 over 3 times by 3 over 1, because 3 is the same as 3 over 1. When you're multiplying fractions, you simply multiply the tops, the numerators, and then multiply the two denominators. So when I multiply 2 times 3, I get 6. 3 times 1 is 3, plus 7 over 3, which equals 13 over 3. All right, we're moving on to question 3. In question 3, we're asked to solve for y, and we want our answers to be rounded to the nearest hundredth, which means 2 decimal places. So that means 2 digits after the decimal. So I'm going to rearrange and isolate for y and then solve for it. So I'm going to keep my negative 5y where it is on the left side of the equal sign and move my 2 to the other side. So negative 5y equals 8. When I move my 2 over, it becomes negative 2. Now I want my y to be on its own, so I want to divide both sides by negative 5. So the negative 5's disappear, and I'm left with y equals 8 minus 2 over negative 5. Let's simplify that. 8 minus 2 is 6, and 6 divided by negative 5. Now, because the question asked me to round my answer to the nearest hundredth, I need to actually type this into my calculator to get my answer. So I'm typing in 6 divided by negative 5 on my calculator, and I get negative 1.2. It wanted it rounded to the nearest hundredth, so it wanted 2 decimal places, so I could just add that extra decimal, which is a 0 at the end. And that's all. Okay, so that was A. If I move on to B, I'm going to do the same thing. I'm trying to solve for y here. So think about how would you isolate for y first. So solving for y means isolating for it like we did here, but then afterwards you're actually going to type it into your calculator, find the answer, or simplify it. Since the question tells us to round our answers to the nearest hundredth, it's saying type it up and get the decimal. If it didn't say that, we could have kept it as a fraction, 6 over negative 5. Okay, so for part B, we want to figure out how we're going to isolate for y. Well, remember in a previous question, when we wanted to get rid of the squared, we plus or minus square rooted it, the other side, to get rid of it. Now in this case, that doesn't really work because we have another y squared on this side. So rather than doing that, what we're going to do is expand the left side of the equal sign. So expanding y minus 2 squared is not as simple as just saying y squared minus 2 squared, which is what a lot of people end up doing. That's a really common mistake. What we want to do whenever a binomial, so 2 terms, is squared, is you want to write out the binomial y minus 2 twice, because that's what squaring something means. It means multiplying by itself. Now we want to expand the left side, so we're going to do FOIL, which means we're multiplying the firsts, so the y times the y, then the outsides, y times negative 2, then the insides, and then the lasts. So that's called FOIL. Another way to think of it is you're just multiplying by the first term by each of the 2 terms here, and then you're multiplying the second term by each of the 2 terms. That's all. So let's do that. Y times y is y squared. Y times negative 2 is negative 2y. Negative 2 times y is also negative 2y. And negative 2 times negative 2 is positive 4. Equals y squared plus 6. Now we're going to bring everything that has y's in it to one side of the equal sign, everything that doesn't have y's in it to the other side. So I have y squared, and I'm going to put them in order, so y squareds come first, then y's. So y squared, I'm going to bring this y squared over to the other side, making it negative y squared, because it used to be a positive. Then I have minus 2y, minus 2y. I didn't move any of them from one side of the equals to the other side, so that's why I'm not changing the signs. Equals, I'm leaving the 6 where it is, and then I'm going to move the 4 to the other side. It used to be a plus 4, now it's a minus 4. So let me simplify this now. Y squared minus y squared, well, that's like saying 1 minus 1. Cancel out, gives you 0. So that's gone. Negative 2y minus 2y is negative 4y. Equals 6 minus 4 is 2. Now we want to divide both sides by negative 4 and simplify. So we're left with the negative 4's cancel. Y equals 2 divided by negative 4, which is negative 0.5. The question asked for 2 decimal places, rounded to the nearest hundredth, so I'm just putting that extra 0 there. And that's it. All right, so notice that in part B, it looked like we had a quadratic, meaning the biggest exponent was squared, right? We had some squareds happening. But what ended up happening when we simplified was that the squareds just canceled each other out. So in the end, the equation we were left with was linear. So we didn't need to use the quadratic formula. But in part C, you'll see that it is quadratic because the biggest exponent is 2, and it's not canceling out with another y squared like it did in part B. So we're going to have to use the quadratic formula. We can't isolate for y here because we have a y squared and a y in our equation. So the quadratic formula, I'm going to rewrite it over here. It's always the variable that you're looking for. So in this case, it's y equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So what is this a, b, and c? So the a, first of all, your equation needs to be in standard form, which means that the y squared term needs to be first, the y term is second, and the plain number is by itself third, and then equals 0 on the right side of the equal. Okay? If it's in a different order, you want to rearrange so that they're in the right order. So the number in front of the y squared is your a. The number in front of your y is your b. And the number in front of your, or the number that's just by itself, the constant, is the c. So in this case, our a is the number in front of y squared. Well, there's nothing there because there's just 1 y squared. So a is 1. The number in front of b is just 2. And the number in front of c is 3. Now, keep in mind that these are plus signs in front of the 2 and in front of the 3, and that's why the b is positive 2 and positive 3. But if it said minus 2y, for example, then our b would be negative 2 instead. Okay, so be very careful that you're keeping in mind that this sign goes with this number here together. All right, so now that we know what our a, b, and c are, we just have to plug them into the quadratic formula. So I have y is equal to negative b. That means whatever b is, change the sign of it. So it used to be a 2, now it's negative 2 plus or minus the square root of b squared. So take that b, put it in brackets, and then square it. Those brackets are especially important if b happens to be negative. You need to make sure you're putting them in brackets. Otherwise, if you type it on your calculator or do it by hand, you'll get the incorrect answer. Minus 4. Now instead of a, we're going to put in a 1. And instead of c, we're putting in a 3. All over, now remember this line goes under the entire equation, not just the square root part, but the negative 2 plus or minus square root section. The whole thing, 2 times a, which is 1. Okay, so you should be able to just type this into your calculator. If you're doing it on your calculator, it depends on what model calculator you're using. Some models allow you to type something in the numerator and in the denominator separately, and so you would simply just be typing it as you see it, once with a plus, and then retyping it a second time with this minus over here. Okay, so you would type this question out twice. If you're doing it by hand or step by step, then That's what we're going to do right now. That's fine as well. If you don't have a calculator that has like a numerator and denominator button like this, then you might find it easier to do it step by step. Otherwise, you'll have to use a lot of brackets when you type it in. So make sure you're trying this on your own calculator so that you know how to use your own calculator for these questions. So if you're going to do it step by step, you would start by finding out what this square root term is. So you can start by just figuring out what's inside the square root. So 2 squared minus 4 times 1 times 3, and you get negative 8. And you can simplify the bottom as well. 2 times 1 is 2. Now, the next thing you would do is type square root of negative 8 to figure out what that is, and you would do one step at a time until you just were left with a decimal. And you would have a positive, like an answer with the plus sign, and a separate answer with the minus sign when you enter it on your calculator. Now, what's going to happen when you enter the square root of negative 8 on your calculator? You're going to end up getting an error because there are no numbers that multiply by themselves to give you a negative. A positive times itself will be positive, and a negative times itself will be a positive as well. So this will never give you an answer. So this will always show you an error on your calculator, which means that there are no solutions here. Okay, so this question has no solutions. Once you realize that there's a negative sign in the square root, then you're done. You just have to say there's no solutions, and that's it. Okay, let's move on to part D. If you feel like you can do this on your own, just please pause the video and then continue on with us when you're ready to check to see if your answer is correct. Okay, so the first thing we want to do is make sure that the equation is in standard form, like it was in part C. That means the y squareds come first, the y's come second, and then just the numbers on their own come third, equals 0 on the right side, because nothing else is left on the right. So I'm going to start by rearranging everything. So this negative 2y squared, that's going to move to the other side of the equal sign. So I have 3y squared, and instead of it being negative 2y squared, it's going to be positive 2 because it's moved from one side of the equal to the other side. Next I have minus 7y plus 3y, so I'll put those in. Those have not been moved from one side of the equal sign to the other, so their sign stays the same. Then I have this plus 4y over here. This is also going to move to the other side, so it's going to become minus 4y. Now I have this number, plus 3. It didn't move from one side of the equal sign to the other, so it stayed as a positive 3. And now I have this 5, which does move from one side of the equal to the other, so it becomes minus 5. Equals, what's left on the right side? Nothing, so it's just equals 0. Okay, we're not quite standard form yet because we have to collect like terms. We just want to see y squared, y, and a number equals 0. We don't want to have so many terms. So we're going to collect like terms. 3y squared plus 2y squared is 5y squared. Minus 7y plus 3y is minus 4y. Minus 4y again is minus 8y. Plus 3 minus 5. So 3 minus 5 is negative 2. Equals 0. So this is great. Now we're in standard form, and we can identify what our A, B, and C values are. The order is correct. The squared term comes first, then the plain variable, and then just the number on its own, equals 0. So what is our A, B, and C? A is equal to the number in front of the y squared, so that would be 5. B is the number in front of just the y. Remember that the negative goes with the 8, so it's negative 8. And C is the number by itself, negative 2. So I'm going to write the quadratic formula. The variable we're looking for is y, so it's y equals. If the variable was x, it would be x equals. Y equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so now I'm going to just enter all of the a, b, c variables that we know into brackets. So negative b. So I have negative of negative 8. So the opposite side of negative 8 would be positive 8. So that's what this negative b means. Change the sign of b. Plus or minus the square root of now b squared. Remember, you have to put the negative 8, which is your b, in brackets. Minus 4, your a is 5, and your c is negative 2. All over 2 times a, which is 5. All right, so now we're going to simplify. So I can type this into my calculator all at once. So I'm going to do that. When I type it in my calculator, the first button I press is a button that looks like this. It might look a little bit different on your calculator depending on which model you have. It looks like this. And that tells me that it's a fraction button, and I get to see what's in the numerator, what's in the denominator very clearly. So I'm going to start by pressing that button, and then I'm going to type what I have on the top, but I'm going to start with just this plus sign here. Okay, I'm going to use the plus first, and then I'll retype it with the minus. So what I'm actually typing is 8 plus the square root sign, and now my square root sign has a little box inside, and everything that I type in this box stays within the square root sign. If your square root sign looks like this, and then everything you type is next to the square root sign like this, for example, then your calculator will think that only this first term is being square rooted. It won't know that the whole thing is supposed to be in the square root sign. So if this is what your calculator is looking like, you need to put all of this in another bracket. Okay, my calculator puts everything under the square root sign, so I know it's all being square rooted. So I'm going to type it all up. I have negative 8 in brackets, close the bracket, squared, minus 4, bracket 5, close the bracket, bracket negative 2, close the bracket, and then I'm going to move down to the denominator now, and I'm going to type 2, bracket 5, all at once. And I get 1.8, so it says 1.8198. My question asked me at the top to round to the nearest hundredth, 2 decimal places. So I only want these 2 decimal places here. 1.8. This little dot on top means approximately equal to. Now I need to decide, is my 1 here going to stay a 1, or is it going to get rounded up to the next number, a 2? And to decide, you just look to see what's next. After the 1 is a 9. That number 9 is 5 or bigger, so the 1 gets rounded up to a 2. So I get 1.82. Now I need to recalculate this answer, this time using the minus sign over here instead of the plus. So I'm going to retype this equation with the minus sign. So I have 8 minus the square root of negative 8 in brackets squared minus 4 times 5 times negative 2 all over 2 times 5, making sure that all of that that I just wrote was in the numerator, and the 2 times 5 is in the denominator, and I get negative 0.2198, and when I round that, the 1 should get rounded up to a 2 because it's followed by a number that's 5 or bigger, so I get negative 0.22. All right, moving along to question 4. So now I have an equation, 1/2 mv squared equals mgh, and I want to isolate for h. So this variable here, I want it to be on its own. Okay, so that means I need to get rid of the m and the g. Okay, so if you think you know how to do this, go ahead and try it out, pause the video, and then continue on with us once you're done. All right, so between the m, the g, and the h, what is that operation? Is that a plus, a minus, a times, or division? Everything is just next to each other. So when things are next to each other, like for example, if I had 9x, what's between the 9 and the x? It's multiplication. Same with this. M, G, and H are all being multiplied by each other. So the opposite of multiplication is division. So in order to get rid of M and G, we need to divide both sides by M and G. So I'm going to start by just rewriting the equation. 1/2 mv squared equals mgh. And I'm going to divide both sides by mg. So what happens? The m and the g cancel out on this side so that h is on its own. And on the left side, the m's cancel out. So what are we left with? We have 1/2 v squared over g is equal to h. So normally when you're isolating for a variable, you want that variable to be on the left side. So I'm just going to rewrite it as h is equal to 1/2 v squared, 1/2 v squared over g. I'm going to write divided by g this way, divided by g. And you'll see why. It's going to make it look a little bit more simple. G is the same as g over 1. When you divide by a fraction, it's like multiplying by the reciprocal or the flip of that fraction. So I'm going to do 1/2 v squared times 1 over g. So when I multiply everything, I'm going to multiply the two numerators, 1v squared times 1. I'm left with just v squared, because 1v squared is the same as v squared, over 2g. So that looks a little bit more simple than this did over here. But it's the same thing. V squared over 2g, or 1/2 v squared over g, really means the same thing. So either way, you would get the answer correct. Okay, let's move on to part B. All right, in part B it says if g is 9.80 and v is 3.28, then solve for h. So when the question asks you to solve for a variable and it gives you the other variables, the best way to do it is to isolate for the one you're looking for first and then substitute the values in after. It's better to do that than to sub in the values first before your variable is isolated. So that's why I made you do part A first, isolate for h, and now in part B we're going to solve for h. So from part A we have h is equal to v squared over 2g. Now we want to sub in the values that we know. V is 3.28 in brackets squared over 2 times g, which is 9.80. Now I'm just going to type this into my calculator. Again, I'm using that button that looks like a fraction button. Looks like this on my calculator. So when I type it, I can see exactly what I'm typing in the numerator and what's in the denominator. So I'm entering 3.28 squared, and then moving to the denominator and typing 2 times 9.80. If you don't have that button and you're just using this as a division, you would be writing it this way, 3.28 in brackets squared divided by 2 times 9.80. What's going to happen is your calculator will think that you're only dividing by 2, and then you're timesing your answer by 9.8. It thinks you're doing this. It doesn't understand that the 9.80 is actually in the denominator. So if your calculator doesn't have a button like this and you're using this division button, you're going to need to remember to put in an extra set of brackets here, telling your calculator that you want to divide by 2 times 9.80. You want it to be in the denominator. Okay, so that's why I want to make sure that you're typing these questions out on your calculator and you're getting the same answer as me so that you know how to use your own calculator, because every calculator is a little bit different. All right, so when I type this up, I get 0.548897, and so on. Okay, keeps going. So I wanted this to be rounded to the nearest hundredth, 2 decimal places, which means these two right here. So I'm going to either leave it as 0.54, or the 4 is going to increase by 1. So should it stay a 4, or should it go up to a 5? Well, you know the answer by looking at the next number. The next number is a 5 or bigger, then you round it up. So the 54 becomes 55. If the next number was 4 or less, then you would keep it as 54. And that's it. All right, so you should be able to continue on with part C or D because it's very similar. You're starting off with the same equation that's at the top. This time you're isolating for V. Okay, so pause the video if you want to move on your own, and then continue with us when you're ready. So I'm going to rewrite the equation. 1/2 mv squared equals mgh. And I want to isolate for v. Okay, so I'm going to rearrange the equation so that the v is on its own. So I need to get rid of the 1/2 and the m. Okay, so I can do them at the same time if I want, or I can do the 1/2 and the m separately if I'd prefer. Let's do them all at once. I'm going to get rid of the 1/2 m by dividing both sides by 1/2 m, because they're being multiplied by the v squared. So what do I have left? On the left, the 1/2 and the m cancel with what's in the denominator, and I'm left with v squared equals. On the right side, the m's cancel, and I'm left with gh divided by 1/2. Now I can leave it like that, but it looks a little bit messy to have a fraction on the bottom. So instead I'm going to write divided by 1/2 like this, and then simplify. So remember, dividing by a fraction is like multiplying by the reciprocal or the flip. Well, what's the flip of 1/2? The 2 goes on top, and the 1 would be on the bottom, but 2 over 1 is just 2. So you would just be left with gh times 2. And gh times 2 is just 2gh. Okay, now we still need to isolate for v, which means that squared needs to go away. So we have to get rid of that squared. So how do you get rid of a squared? The opposite of squaring something is square rooting it. But remember, you have to remember not to forget the plus or minus that goes in front. So I'm going to write square root of v squared equals plus or minus the square root of 2gh. So my squared and my square root will cancel out. I'll be left with v is equal to plus or minus the square root of 2gh. And that's it. Okay, so that's C. I've isolated for v. Now I'm ready to do part D, which is asking me to solve for v because I know the values of g and h. So since v is already isolated, this step is quite easy. It's best to isolate for your variable before you start to substitute your values in. So I have v is equal to plus or minus square root of 2gh. And now I'm going to start to sub in. My g is 9.80 and my h is 2.19. Everything is inside the square root sign. So I'm just going to type in the square root of 2 times 9.80 times 2.19, making sure it's all in the square root sign, and I get plus or minus 6.55164, and so on. I only want 2 digits after the decimal place. So I need to decide, am I going to round the 5 up to a 6, or is it going to stay as a 5? So I'm going to put approximately equal to. Now, because after the 5 is a 1, that number is smaller than 5. That means that this 5 over here does not get rounded up. It stays as it is, a 5. And that's it. So we've solved for v. Okay, I'm just going to write v equals at the end. Awesome. Number 5. Number 5 is asking us to rearrange this equation, it's a rather long one, to isolate for a. Okay, so we just want to solve for that a. We want a by itself. That means we need to get rid of everything that's surrounding the a, starting with what's the farthest away from a, and then moving inwards until we're left with just a by itself. So let's start by getting rid of this v initial squared. We're going to move it to the other side of the equal sign. So we have v final squared minus v initial squared equals 2a s final minus s initial. Okay, now we need to get rid of the 2 and the s final minus s initial. The 2 and the s final minus s initial are both being multiplied by a. So they're both being multiplied, so to get rid of them, we need to just divide them out. So I'm just going to divide both sides by 2 sf minus si. So what's happening here? The 2's will cancel, and this whole bracket will cancel, and it will leave us just with that a. So I'm going to do that on both sides. Whatever I divide by on one side, I need to do to the other side. And what am I left with? V final squared minus V initial squared over 2 SF minus SI equals A. So normally when you're isolating for something, you want it to be on the left side of the equal sign. So I'm going to rewrite this just to put it in reverse order. A is equal to V final squared minus V initial squared over 2 SF minus SI. And that's it. Awesome. All right, moving on to question 6. We have this long equation, SF equals SI plus VI delta T. This little triangle is called delta, plus 1/2 A delta T squared. If SI is 0, and SF is 3.23, and VI is 21.3, and A is 9.80, then what is delta T? Okay. So in the past I've said that if you're trying to solve for a variable, you want to isolate it first. And then once you've isolated it, so once it says delta T equals a bunch of other variables, you would just substitute in those values. This time, however, it's not possible to isolate for the delta T because you can see that it's written there twice, delta T and delta T squared, which makes this a quadratic equation. The biggest exponent is a 2. So in cases like this where the quadratic formula needs to be used, you're going to want to substitute your values in first. So that's what we're going to do here. I'm going to sub in my SF, SI, VI, and A into this equation. We'll see that we're left with a quadratic equation. Then we'll use the quadratic formula. So my SF is 3.23 equals my SI, which is 0, plus VI, which is 21.3. Delta T is what I'm looking for, so it's going to stay as delta T, plus 1/2. My A is negative 9.80, and then delta T squared. So remember that when you're using the quadratic formula, everything needs to be in standard form, which means that the delta T squared term comes first. So I'm going to rewrite everything in the correct order. So all of this needs to be moved to the other side of the equation. Remember, when you're moving things to the opposite side of the equation, the plus sign that you see here will have to change to a minus. So I have negative 1/2, negative 9.80. Now you don't change both of the signs. This is all one big term over here. And you're going to move everything over, so you just put in one negative sign, times delta T squared. Now the 21.3 delta t also needs to get moved over to the other side, so that's going to become negative 21.3 delta t. The 3.23 stays where it is, equals, and we're just left with 0 on the right side because everything else is gone. Now we can simplify. So we can type on our calculator negative 1/2 times negative 9.80, and we get 4.9 delta t squared minus 21.3 delta t plus 3.23 is equal to 0. Now this looks great because it's in standard form. The delta t squared term comes first, the delta t term comes next, and then just the plain number by itself is last, equals 0. So let's identify our A, our B, and our C. Remembering that the plus or the minus that's in front of the number is still part of the A, B, or C. Okay, so A is positive 4.9, B is negative 21.3, and C is positive 3.23. So the quadratic formula will be given to you on a test. Let's write it out here. The variable we're looking for this time is delta t is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So my negative b, the negative just means to change the sign of whatever the b was. So b is negative 21.3, so negative b is positive 21.3, plus or minus the square root. My b needs to be in brackets, squared minus 4, a is 4.9, and c is 3.23, all over 2 times a, which is 4.9. Okay, so now I'm going to type this into my calculator. I'm going to type it out twice, once with a plus and once with a minus. So I'm going to use the fraction button, 21.3 plus the square root, bracket, negative 21.3, close the bracket, squared, minus 4, bracket 4.9, and then another bracket 3.23, and then move on to the denominator. And in the denominator, 2 bracket 4.9. Close the bracket, and I have 4.1896 with some more decimals. That's what I get when I put in the plus sign. And then I can go back on my calculator, I can go back to my actual equation and just change the plus sign to a minus without having to retype it. Depends on the calculator that you have. So I'm just going back and changing this plus sign over here that I typed originally into a minus. So I'm going to do the minus next. You might have to retype it all over again. And when I do that, I get 0.157338 with some more digits. Okay, so now I'm just going to round it to the nearest hundredth, meaning 2 decimal places, 4.18. I need to decide, does this 8 stay as it is, or does it get rounded up to a 9? So because it's followed by a number larger than 5, it will get rounded up to a 9. I do the same thing with my next number, 0.15. I decide whether that 5 is remaining as a 5 or if it should get rounded up to a 6. Because it's followed by a 7, which is bigger than 5, I'm going to round it up to a 6. And that's it. So those are my 2 answers, 4.19 and 0.16. So that was our final question. Hope that all helped. Thanks for watching.